So let's do problem 5. It won't take very long. It's a very short problem. So match the function on the left with its most plausible inverse on the right. Okay, so how do we, what is going to make this work? You know that a function, its inverse is just a reflection across the diagonal. So the diagonal line is the line that's described by y equals x. So what we're looking for is we're going to see a picture on the left and we're going to match it with a picture on the right, which is most nearly its reflection across that diagonal line. Okay, so let's just do A first. So the answer is pretty clearly not I, pretty clearly not 2, pretty clearly, oh, well, it is 3 actually. So this is an example of a function that's its own inverse. And any function that's symmetric, you could say that it's symmetric about the diagonal. Okay, so it's its own inverse because if you have a point over here like a comma b, then the flip point b comma a is also on the graph. And so this is an example of a function that's its own inverse, and if you can see like a hawk, you might be able to read that that says 1 over x. So 1 over x is an example of a function that that's its own inverse. So a goes to 3. I. Okay, so A is done. By the way, the reason that the picture looks a little warped, you can see that these rectangles are 1 by 1, but they're not square, are they? It's because the graphing program doesn't have an aspect ratio of 1 to 1. So it counts horizontal distance a little more than vertical distance. I'm sorry, I tried to fix that, but it doesn't have an option to correct that. So let's do B, okay? Alright, so we're looking at B and we want to find a picture on the right that describes its inverse. But you can see that B is not invertible. So its inverse is not going to be a function because it's not 1 to 1. Right? So here we have something like this is A1, here's A1 on the x-axis and here is A2. And both A1 and A2 get sent to this value B on the y-axis. So if we were to do the inverse, where is B going to get sent back to? Right? It's either A1 or A2, but it's ambiguous. And so the inverse of B does not exist. So B gets matched to 4 here, which does not exist. So B goes to 4, or B equals does not exist. Okay, and let's do C. So here is C, and let's make the diagonal line. Man, I'm really doing a dynamite job with those diagonal lines. And so what over here on the right looks like a reflection across the diagonal of that? It's I. Right, so see how I is the reflection across the diagonal of the picture from C. There it is. There's its reflection. So C goes to 1. And so it's pretty obvious where D goes, I guess. So this was 4, 3, 1. D must go to 2. But let's see why. Okay, so here it is. And we're looking for its reflection across the diagonal. And its reflection across the diagonal is the picture in 2. Okay, so indeed, D goes to 2. And that's all there is to this question. Very easy.